Hello, everyone at State Band Choir and Orchestra. Say hi, everybody. Hi. Okay, we're missing a lot of people, so I am so kind to record this lesson for you. I hope you enjoy it. Let's start off with a joke today. I do. Savannah says I do a different voice. Okay, I'll talk more normal. Um, where did the colonel keep his armies? The colonel kept his armies in his sleeveys. Okay, you guys, we are on 7.3. We're jumping around. Today is called partial fraction decomposition. What does it mean? What does decomposition mean? Take apart. You're exactly right. Today is the 16th. So we are going to take apart fractions. And you need this for anti-differentiation, which is a calculus thing. Okay? So basically, here's the example that I'm, without being too difficult. 10 over 13, we're trying to figure out how to break that up. Well, you guys know that if you broke up a fraction that simply, there's probably a lot of different answers, but one answer could be 6 over 13 plus what? 4 over 13. So your job is to take a fraction and make it into pieces. And that's because probably the pieces are easier to anti-differentiate than the whole thing. What kind of function is it when it's a fraction? Starts with an R. Thank you, Katie. Rational. Okay. So these will all be rational functions. Here's what it'll look like with variables. 3x squared minus 9x plus 5. We're going to take that apart. It has a denominator already, x squared minus 9. So this is what will be given to you. Your job will be to do a lot of hocus pocus, a little bit of math, everything I teach you. And your job is to break it apart into two pieces. The pieces will be 3x over x plus 3. And you're not just supposed to know this, you've got to do math. Plus 5 over x squared minus 9. Now, if you guys were working from right here, let's say this was the problem in front of you. What would you have to do to simplify that? Sean? Yeah, you guys would look at this, and if you were simplifying it, you need a common denominator. So you're thinking, okay, I need to take this x plus 3 and multiply it by what? X minus 3. Good. Okay. And you do that on the top and on the bottom. So basically what you're doing is you're going to take a fraction, split it up, and you're going to set yourself up to figure out what these numerators are supposed to be. It seems a little bit daunting, but it's really not that bad, okay? So let's write down the first example, and then we'll go to lunch. Okay, so example 1, we're going to take 2 divided by x squared minus 8x plus 15. And we'll see you guys on the video. We're coming back. We got to go lunch. See you in a few. Okay, the first thing you're going to do, step 1, I'm going to write steps over to the side. You're going to factor the denominator. Who can factor this for me, please? Someone other than Sean. Zach. X minus 5 and x minus 3. You guys, that will always be your first step in partial fraction decomposition, okay? Step 2, you're going to separate the factors. Okay, so what that means is we're going to take x minus 5 and put it on this side. We're going to add that to the denominator x minus 3. Now here's the weird thing. What we're focusing on is the fact that this factor right here, if we could classify it, does it make sense for me to use the word linear? Okay, you understand why this is a linear factor? That will matter later, okay? It's a linear factor down here. When it's a linear factor, what you're going to hold the place on the top in the numerator, you're going to put an a value. A represents a constant. Okay, so if you have something linear, which is to the first power, a constant has an x to the 0 power with it, so that's why we put a constant above it. It's kind of like one less level, all right? Over here, is this also linear on this side? Yes, so you put a constant above it, okay? So this is a constant, meaning a value like 5 or 3 or something. We don't know yet. Okay, now, what we need to do is we need to figure out what this numerator is, and the only way we can do that is to set this numerator equal to this thing. So here we go. It'll be a over x minus 5 plus b over x minus 3 equals 2. Do you guys see why it's equal to 2? Because this thing right here, this piece, this whole thing, needs to be equal to this. We're trying to take that fraction and break it up. And I forgot. Does anybody know what I missed? If it's going to be equal to the whole thing, then I need x minus 5 and x minus 3 down here also. Okay, now the next step is, you guys, from here, these are things that you've done before. Right now, you're solving a rational expression, okay? So step 3, go back a little bit. I know I'm out of order. You choose your numerators. In this case, your numerators were constants. They were a and b. You set up your equation. Step 4 is to set up a rational equation. What do you think you need to solve for? Solve for a and b. Okay, here we go. If we were going to solve this equation, you guys would need to work over here first, because it's helpful if this denominator is the same as this one. So I would multiply this x minus 5 times what? X minus 3, and if you do that on the bottom, you have to do it on the top. What does this x minus 3 get? An x minus 5. Okay, now here's the trick. If all of your denominators are the same, you don't have to worry about them at all. You can get rid of them and just focus on the numerator. So write down x minus 3 times a plus b times x minus 5 equals 2. There's 2 ways to solve this. I'm going to show you both ways today. Okay. The first way I'm going to show you is longer. I think you'll like the second way better, but this one kind of makes more sense to me. Okay, so what we're going to do from here is we're going to distribute ax minus 3a plus bx minus 5b equals 2. From here, you need to group things, okay? So here we're grouping We're going to group things that are linear, and we're going to group things that are constant. So who can raise your hand and group for me the linear things? Linear are, those A's are just numbers, kiddo. So the 3A is not linear. So what's one of the linear things? Savannah? Yeah. The linear part is AX plus BX. Those are both linear because they have X to the first power in them. Then we're going to gather our constants. What constants? So we put these together. Now we're going to gather constants. So it'll be minus 3A minus 5B equals 2. So I'm just going to call these constants. Okay, now here's how you need to think about this. Really, instead of having a 2 here, we should change it, and I'm just going to cross it out and change it. It's 0x plus 2. There are no linear parts over there because there is no x on the other side. Does that make sense? Can you give me a nod? Okay, there's no x's on the other side. So you're going to set up a system. You know that a plus b, or sorry, let's do it this way. A plus b x equals 0x. And you know that negative 3a minus 5b equals what? Not 0. It equals 2. That's the constant part. Okay? So here's what you have. This x really doesn't matter here. I'm going to get rid of it. These x's can go away because all we care about is creating a system. Okay, so a plus b equals 0 and negative 3a minus 5b equals 2. How many of you guys remember how to solve a system? You do? Okay, so let's make a note that this is a system down here. Let's say solve for a. So what does a equal? Let's do it this way. Solve for a. A plus b equals 0. So a equals negative b. Okay? Take that value and substitute it back into the other equation. All right, so I'm going to take, we'll use a different color. I'm going to take my negative 3a minus 5b equals 2. And what am I going to change this a to? Negative b. So negative 3 times negative b minus 5b equals 2. That's 3b minus 5b equals 2. Negative 2b is 2. What does b equal? Negative 1. What does a equal? If a equals negative b, that's the opposite of negative 1. So a equals 1. Okay, here's what you just did. I know it seems a little confusing. But what you just did, if you go back up to this line right here, this is what you were trying to do. It's a over x minus 5 and b over x minus 3. A over x minus 5 plus b over x minus 3. And you're going to substitute for a and b. So what do I put over this one? 1 over x minus 5 plus, what goes in here? Negative 1 over x minus 3. I promise you, this has huge benefits in calculus. That's the answer. And if you guys went through and simplified it, you'd get 2 over x squared minus, what was it, 8x plus 15? You guys act funny when I'm talking on the microphone. You're quieter. You're not dumb. You're not dumb. Um, do you think you could do one by yourself, or do you need me to do another one? Okay, why don't you just try one? Okay. This brings in so many good skills. Factoring, solving a system, and putting Zach to sleep. Okay, Nico, what's step one? Oh, Zach, who's sleeping, wants to answer. Zach, what's step one? Okay, so we have 3x minus 4 over, Zach, factor for me, x times x minus 2. Okay, you guys essentially can skip a step, kind of, and you can separate your factors here, x and x minus 2. Are both of those denominators linear? Dante, are you sure? No. The exponent on this x is a 1. That means it's linear. And the exponent on this x is a 1. So if they're linear, what did I call it? What goes above them? Constants. So we're going to put an a up here and a b up here. And you set this equal to your original problem. 3x minus 4 over x times x minus 2. It's just easier if it's factored. Okay, you think of the next step. Set up rational equation. I just did that. I need to, yeah, solve it for a and b. Okay? If we're going to solve this, we need common denominators. So what do I multiply the first term by? Help us out, Alex. Good. X minus 2 on the top and on the bottom. And then, Jake, what about the next term? An x. Good. Okay, now all we care about is the numerator. So we have, can I do the other way this time? The other way is better. Check this out. I'm going to do a times x minus 2 plus bx equals 3x minus 4. Okay, someone impress me and graph a rational function in the air. Need two hands. Oh, no, no, no. It's like this. I quit looking. Okay. Yeah, it's the one that it kind of has some decay and then like a logarithm. I like it. Okay, now, isn't it true that there are an infinite amount of x values that exist on those? Oh yeah, you guys can't see my rational function. Jake is helping you guys. Rational function looks like this. Neural, neural. Not a good grapher, don't have time. Okay, are there an infinite amount of x values? Yes. So here's what you can do. You can set this up to solve it and make it really easy. You get to pick really awesome numbers, okay? So pick awesome x values. No, 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 no. What's an awesome x value? No. 2. If you let x equal 2, you're going to get rid of this a. Okay? So let's do that. Let's say a times 2 minus 2 plus b times 2 equals 3 times 2 minus 4. This is gone because it's 0. So 2b equals what? 2b equals, you like that way better? Okay. Now, you still have to get your A value. Pick another great X value. Yeah, this time pick 0 because you want to get rid of the B. Okay? So the second time, let X equals 0. So we're going to do A times 0 minus 2 plus B times 0 equals 3 times 0 minus 4. Mr. Rose taught me this morning. I'd never done it this way. It's awesome. So negative 2A equals negative 4. What does A equal? 2. Your final answer, remember, it comes all the way, sorry, I'll go back down. It comes all the way from back right here. A over X and B over X minus 2. A over X, B over X minus 2. Sean. Okay, what I want you to do, kiddo, is I want you to go ahead and multiply this out for me. And you will get 3x minus 4 over x squared minus 2x. It's just taking it and splitting it in parts. Okay, those of you that are watching on video, you need to click on the pre-calc honors link to see what the assignment is because I need to modify it. So I'm going to sign off, and I hope you guys had fun. They're making fun of me. Would you believe that? Adios.